Hi guys, so this is the fourth video on Math SL, differentiation, chain and product and quotient rules. In this video we shall focus specifically on problems that require your knowledge of trig exact values, and these are the paper 1 problems right there on the screen, and two other problems that require you to sketch the curve using your GDC, your graphic display calculator. So these are two sets of problems, they're not tackling the same concept. You can feel free to forward to the second half of this video if you're only interested in sketching. If you're interested in trig exact values, you can watch the first half of this video as well as our previous video, the third video in this series, which tackled slopes and stationary points, because this also had trig exact value problems. I'll begin the first question shortly. So the first problem we are going to tackle came in paper 1, May 2009, time zone 2, question number 8. Kindly take a minute to pause the video, try to solve this on your own, and then check the answer out. So question A requires that you use the chain rule to differentiate the two functions given above. And of course I'm going to go through this quickly. You can watch the video that introduces the differentiation process using the chain rule for more detailed solutions. So if f of x is equal to e to the negative 3x, then the derivative is going to be negative 3e to the negative 3x. If g of x equals sine x minus pi over 3, then the derivative of that shall be cosine x minus pi over 3, and there is no application of the chain rule here because the derivative of the inside function is simply 1. X minus pi over 3 differentiates to 1. Now in question B you are required to use the product rule, because we have h of x equals e to the negative 3x multiplied by sine x minus pi over 3. This is a product of two different functions. We're going to use the product rule, uv dash plus vu dash, and I've used the same colors in this expression as the ones above so that you can relate. Take a minute to look at the answer before I move on. So we used the product rule to obtain an expression for h dash of x, the general derivative function, but the question requires that we find the exact value of h dash of pi over 3. So what remains for us to do is to substitute x for the required value, which is pi over 3. And that's what I did in the subsequent step. So in this blue expression right there, all I did was I removed every single x in the first expression and I substituted pi over 3 throughout the entire expression. After I do that, all that remains is to simplify and find the exact values. So for the first component, negative 3 times pi over 3 gives me negative pi. Cosine pi over 3 minus pi over 3 is the same as cosine of 0. Same goes to sine pi over 3 minus pi over 3. That also gives me sine 0. Finally, negative 3 times pi over 3 in the exponent gives me again negative pi. Now you have to be aware of the trig exact values. So cosine of 0 is 1 and sine of 0 is 0, which cancels this part of the expression. And all that remains for me is e to the negative pi times 1, which gives me a final answer of e to the negative pi. So take a minute to copy this down if you will. I'm about to start the second question shortly. So the second problem we are going to tackle in this video came in paper 1, May 2011, time zone 2, question number 4. So far we are still in the domain of problems that tackle trig exact values. Take a minute, pause the video, try to solve this, and then check your answer out. So in this problem we are required to differentiate the function 6x over cosine of x. We are obviously going to use the quotient rule, vu dash minus uv dash over v squared. Then we are going to simplify. I simply rewrote the expression in a nicer way. So from blue to green, these are pretty much the same expressions. And then I replace the x in the green expression with 0 because I'm required to find h dash of 0. So 6 cosine of 0 plus 6 times 0 sine 0. We know that cosine 0 is 1 and sine 0 is 0. So this gives me 6 over 1, which gives me 6. Take a minute to check the answer out. Write it down if you will. I'm about to start question number 3 shortly. So the third question we shall tackle in this video came in paper 2, May 2010, time zone 1, question 3. This falls under the category of sketching. Take a minute to pause the video and attempt to answer before I start the solution. So for question A, you have the function x times cosine of x. You are required to differentiate. This is a simple application of the product rule, uv dash plus vu dash. And in the blue expression, I simply rewrote the purple expression in a nicer way. So x times negative sine x gives me negative x sine x. And 1 times cosine x gives me cosine x. Now, I'm about to start question B. If you'd like to take a minute to copy this down, then pause the video. So for question B, you are required to sketch the graph of y equals f dash of x, which you have already obtained in question A, and we of course have to use the graphic display calculator in order to do that. So the first thing I do is use the y equal button in order to access writing equations, and I type in the equation as I have obtained it in question A. So in question A we found that f dash equals negative x sine x plus cosine of x. So I just simply type that down and then I click on trace in order to find the graph. This is the graph of the function. However, I still have to make sure that I stick to the appropriate domain that they have specified in the question. Let's take a look at that. The question requires that I sketch within the domain 0 less than x less than 6. So I have to adjust that on the window of my calculator. So I go to window, and then x minimum has to be 0 and x maximum has to be 6. Of course you have to play around with y minimum and y maximum until you get an appropriate picture. So let's just start with negative 10 and 10 and see how the graph looks like. We shall now click on trace to see the graph. So this is the required graph and I just have to copy it down, and the answer should look something like this. So I want to go over the marking scheme requirements with you. you are given 1 mark for the correct domain, so you have to sketch from 0 up till 6, and another mark for approximately correct shape, so it has to look similar, somewhat similar to what you have on the calculator. There is the shape that we have obtained, so it kind of looks alright. You are given another mark for the local minimum in a circle and the fourth mark for the local maximum in a circle, so you are required to identify the minimum and the maximum points on the graph, and that's it, you're done. So for the fourth and final question, we are going to tackle paper 2, May 2012, time zone 2, question 2. Kindly take a minute to look at the question, pause the video, and then check your answer out. So this is a direct application of the chain rule. We are given the function cosine e to the power of x, and the derivative of that is negative sine e to the power of x. This is the derivative of the outer function, the cosine function, and we multiply that by the derivative of the inner function, and the derivative of e to the power of x is also e to the power of x. Now in the red expression, I've only rewritten the blue expression in a nicer way. Negative e to the power of x sine e to the power of x. This should make things a bit simpler when I try to sketch this using the GDC, which we shall do next. Now pause the video, copy this down if you will. I'm about to start question B shortly. So question B requires us to sketch the graph of the derivative function that we have obtained, and of course I need to use the GDC in order to do that. I first go to the button y equals in order to write my equation down, and as you can see, I've typed down the derivative function that we have obtained, negative e to the power of x sine e to the power of x. And now I shall click on the window button to match my domain to the one specified in the question. Right there, negative 2 less than or equal x less than or equal 2. So let's just make sure our window is appropriate. X minimum is set to negative 2, x maximum is set to 2, and then for the y minimum and the y maximum I have to use trial and error. I'm just going to plug in any two numbers and then see whether my window works or not. So next we click on trace to see the shape of our function. And the function is approximately within the window. It is well adjusted, well placed within the window, so I don't really need to change my y minimum and y maximum. So all I have to do now is maybe just copy this down on the answer paper, and it should look something like this. So the marking scheme requires that we have the correct domain, obviously, and you are awarded 1 mark for that your sketch extends from negative 2 to positive 2, and then also in the correct range, so your sketch is within the appropriate range, negative 6 to 4, and you should have obtained that from your sketch. Your sketch has to be within the correct range in general, and bear in mind this is approximate to an extent. You have a mark for circling the minimum point and a final mark for the maximum point. Excuse me, there is a 5th mark for the intercepts in circles. So basically, after you create your sketch, make sure to circle the minimum, the maximum, and the intercepts. So take a minute to copy this down if you will, and that concludes our 4th video in this series. I hope you have found it beneficial.